In this problem, we're using the same mean and standard deviation for women's heights, but now we're asking a new question. We're asking, what's the probability that a woman is shorter than 62 inches? And this is where things get a little trickier, so we're going to have to use our calculator. So instead of looking at this middle 68% like we did before, now we're looking at shorter than 62 inches. So 62 is between 61 and 64. So here's 62. And I'm interested in women that are shorter than 62 inches. So here's 62, and the shorter side is people with heights less than that, right? Shorter means less than. So now I'm trying to find the area of this shape. And the 68, 95, 99.7 rule doesn't help me here. But luckily for us, remember the key idea here is that probability is connected to area. Your calculator can actually figure out this area for you. So the special function that we use to calculate probabilities and areas for normal curve is called normal CDF. And I'm going to show you where we find that in our calculator in just a second. But normal CDF needs inputs to do its job correctly. And it needs 1, 2, 3, 4 numbers. So the last two are actually the easiest. It needs to know what the mean of this normal curve is, and it needs to know what the standard deviation for that normal curve is. So we know that the mean of women's heights is 64 inches, and we know that the standard deviation is 3 inches. Now, we also need to know sort of the smallest number we're interested in, or the lower bound. And we need to know the biggest number we're interested in, or the upper bound. Now, in this case, we can see from where the boundary is, the biggest number in my highlighted region is 62. So that's going to be my upper bound. But for my lower bound, this region captures 99.7% of the data, but there could be shorter women over here, shorter than 55 inches. That is definitely a thing that can happen. So for the lower bound, we can either do one of two things. So option number one is you could choose a number that is definitely smaller than the smallest possible height. So if I put 0 here, nobody is shorter than 0 inches. So that would totally work as a lower bound, but it has to fit for the context of the problem you're looking at. Other people prefer to use your calculator's idea of infinity. Okay, so option 2 here is for negative infinity. We would do -1 E99. If you wanted to use positive infinity, if this was a taller than 62 inches, just make a note that positive infinity, you use +1 E99 on your graphing calculator. So I'm going to show you how to put all of this into your graphing calculator now, but basically once we do that, our calculator is going to spit out the area for us, and we know that that's the probability that we're looking for.